If I think I know the answer, but I've never really explored it, I look it up. Number one. Number two, no problem should have to be solved twice is a simple idea. Obviously, you should retread the reinvention of the wheel once in a while. You might discover a better wheel, but you kind of want to put that information out when you have, so people have a leg up when they do their next experiment or lookup. So that's what I'm here for. The purpose of necking down a cartridge. Why are bullets, actually they're cartridges, made in such a way that some of them are basically a metal can with gunpowder in it? It's actually called propellant, but gunpowder we'll call it, with a button on the back, the bang button, aka the primer, and then a bullet sticking out the top. Some of them are just shaped like a Coke bottle, and some are shaped like a bean can. Why? Well, here we go. The chamber and or cartridge case length and volume sets the limits on all things in what happens from the moment of firing the cartridge. The rest of it is the shape of the weapon that the cartridge is put in. The barrel length, in the case of shotgun shells, whether or not the diameter changes internally, whether there's rifling or not. And after that, once it leaves the barrel, there's nothing you can alter. The only thing left over is literally the projectile, the actual bullet. How much it weighs and what its characteristics are. And what it does on impact can be based on its internal structure, whether or not it has a hollow end on it, plastic fillers, tungsten, all sorts of things. So what is going on with the cartridge? The cartridge is the object that is purchased in mass in a bag or a box, and put into a magazine or magazine tube, or put individually. That is the metal casing with the primer on one end, propellant in the middle, and the bullet on the other end. That's essentially what most people get these days, so let's go from there. If you change nothing else and you only change one characteristic of said cartridge, we'll start with this. Large cartridge lengths, larger ones, require a longer loading, extraction, and firing cycle. That means that if you're using, let's say, a bolt action, if you're not aware of it, it's something where you lift up a handle and pull it back towards you, and it reveals the space the bullet goes into. That spacing distance is based on how long the cartridge is when it has the bullet in, but it has to accommodate for when there's no bullet in it. It could be a long or a very short change. This determines how much movement is in that part, and that can be very significant. A faster bullet has less time to drop below the point you've aimed at, so you can more likely hit it or have to accommodate for the drop less. If you have a very fast bullet, the maximum range a bullet may have may be so short that there is no real drop. This is sometimes called a flat trajectory. So making it faster may be an advantage, or not. Some people literally go to the trouble of making slower moving bullets for specific reasons. Faster burning and or more propellant can speed up a bullet. But depending on all the other characteristics we're not including here, this may increase the pressure, this may increase other characteristics, wearing out characteristics. It may require thicker casings for the cartridge. It may require that you do very different geometry for the physical shape of it, hint, hint. A longer barrel may be able to exploit propellant better than a shorter, meaning a rifle or a carbine, which is just a longer barrel, longer barrel and then slightly longer barrel versus a pistol, may be able to exploit the propellant better, but, well, you could use a faster burning propellant and less of it, and maybe get the bullet up to high speed but not have a lot of pressure behind it, so it can only move a certain total amount of mass forward. A longer barrel may be able to exploit powder that may be unburnt in a pistol, and vice versa. You might use less propellant or fast-burning, smaller amount of propellant in a pistol, but it wouldn't work well in a barrel. A longer barrel may add drag to a bullet that would work better in a shorter barrel. A shorter barrel may require faster propellant, period, full stop. But this may create, and it does, massive pressure increases. Pistol propellant in a rifle might be a very, very bad idea. Rifle propellant in a pistol might just produce a big poof of fire and smoke. And gunpowder, being much slower propellant capability, may be safer at, you get the idea. The practicalities of the size of the cartridge. You may end up with a really long spaghetti shot. For instance, 410 5-inch cartridges exist. They're ridiculously large, and they're for firing a lot of pellets out of a shotgun. This is a device that, shotguns, you can put all sorts of crazy things in there. So you see them, and you see that they're impractically long and sometimes get bent or broken. They're long enough that they can be bent. Also, you can make a shotgun on purpose 12 gauge that does the same thing by using a straight pipe. And there is a neck down inside of a 12 gauge, or any other shotgun, called a forcing cone. Most guns, even pistols with straight walls, have a kind of a slight angle to them to be a forcing cone to get the bullet into the rifling. Almost all of them do some form of neck down. Very few go completely straight. A lighter bullet can go faster than a heavy bullet, but may be less stable because a heavy bullet will have the ability, if it's rotating on its axis from rifling, to rotate with its own physical inertia, balancing it out better. It might be able to be more stable, because that way it can prevent itself from incidentally going off track. Also, a heavier bullet hitting something will deflect less often than a light one. But yes, a light bullet or a low-density bullet could go faster. It might even go longer distance. Heavier bullets of the same caliber preserve momentum greater than lighter ones, so the energy you impart at the muzzle, more of it ends up at the target. Also, heavier bullets retain more mechanical energy while going through a target, imparting more energy, or being able to carry it in through for greater penetration. They retain more stability, more foot-pounds of energy at impact, but will be longer than the lighter ones of the same caliber if you use exactly the same materials. Hint, hint. Meaning, if you want to make a really heavy bullet come out of a 22 short, you end up taking a 223-556 rifle bullet and sticking on the end of a 22 short, which looks goofy, but it works. But now it's so heavy it goes slower, but it hits harder. If you're trying to do something at a deliberately short range, you may not need speed, because the drop is incidental. Large caliber bullets hit harder than a smaller caliber, but have more cross-sectional surface area, and they slow down in air more, and also slow down in the target more, which may be an advantage in the target and a disadvantage in air. Bullets that have less air resistance and more range are smaller in diameter cross-sectionally, but can be made heavier by deliberately making them longer. Now we're seeing a reasoning for the necking down thing. You can get more mass if you make a really long bullet, but if it's really too long, it starts having wedge problems and it'll flip end to end like that. So there has to be a happy medium, and spin stabilization sometimes can't fix it. Also, the diameter of it also can be affected by deflection from an object, like a twig. A larger one that's dumpier is more like a round ball. It basically hits, and even if it starts tumbling, it'll still go in a straight line. Long, skinny bullets, tumbling, may go completely off track or may start doing spirals in the air. You can actually see videos of this. A 45 grain 22 Magnum bullet is shorter than a 55 grain 223-556 bullet. But that's not really true, because you could make the 22 Magnum a long, deep hollow point with a filler, and it would be almost exactly the same length. And you can use tungsten instead of normal lead to massively shorten the length of a bullet, so you can end up with a 223 round being much shorter than a 22 Magnum pistol bullet. And remember, you can also put a 22 short in one of those things, and it is literally a 223-556 bullet stuck on the end of a basically BB cap. And you could have the 223-556 use a tungsten and be nothing but plastic or polymer and not even need the length to it. It might even be just a pellet. And there are some rounds that are using that. Some of them do this for target shooting only. They just make them really dense so that on impact they make a definite dent in steel. 22 Magnum straight wall versus neck down on the 223-556 case. Now, the reason I'm bringing that up is this is the most common, really visually obvious example. Basically, if you took a 22 Magnum and stuck a big bottle on the butt end of it, that would be the 223-556 in most people's minds. That's an extreme example. See also the 12 gauge full brass cartridge equivalent, neck down to 50 caliber, we call the 50 caliber Browning machine gun cartridge, aka that big ass gun, the big freaking gun. Yeah, you take the space of a 12 gauge and put a 50 caliber, basically 50 Magnum, Smith & Wesson bullet on the end of it. Except it's also long and skinny, and it's just a gigantically scaled up 223-556 rifle bullet. See also 30-06 and all the others. So why is this done? The term bottleneck versus necked down, or the other one of them is, there's neck down and bottlenecked. Bottlenecking means a cartridge that spreads out the pressure, burning more propellant in a smaller bore in a more compact case. That's a bottleneck cartridge. Necking down means that you start with a straight-walled case in the first place and you change the neck size to accept a smaller diameter bullet. See also, take a 12 gauge and fire 50 caliber out of it. You can get more powder behind a bullet so you can drive it at a higher velocity and stuff it into a case of a reasonable length that won't jam and won't have as many problems. And this compression factor is the same as squeezing a big bulb to get a high speed of air coming out of a small nozzle. Think of big balloon with a cork in it. Also, having it more approximate a complete sphere means that the burning pressure has a spherical casing with the least amount of metal around it and weight. That could be a factor if you're packing thousands of rounds and you're running a machine gun in the military. To push it through a small opening here so that all things being equal, by the time the propellant is ignited from here to here on your sphere, it's got an even pressure wave in it. This becomes very important. The only other way around it is to make a really long case where you fire it from here, and by the time it gets to where the bullet is, the shock wave is already very even. But now you have a non-ideal sphere. It's not a sphere, it's a tube. Spherical shapes have a habit of being stronger, even for extension or distension as well. See also hoop stress. An increased volume of powder in the proportion to bore diameter and propellant volume equals PSI, or pressure, which is a good thing for propelling and speed, but a bad thing for physical strength of the weapon. Longer barrels equals a better speed and exploitation of it, and also flatter paths. So if you're trying to hit a target at a long range, you almost have to use bottleneck cartridges. Or you use long spaghetti cartridges, which means your hoop stressing is pushing on the sides of it more. It actually does work out better to have a big ball or a shorter cartridge that's fatter, so the pressure's evened out over the area and has less impact. Accuracy. A short squat case with a long neck with very little taper, meaning just going instead of even neck down, it just completely comes to a stop, allows a consistent powder burn in a nearly or approximate spherical space. The neck allows more consistent push from behind and a linear push rather than any kind of sideways push at the beginning stages. Grips the bullet better, so you get a better seal, so you get better propulsion. Consistently causes, and this causes a consistency level that you can predict because it's easier to do the math for it, mechanics for it, so you can have better accuracy. Round balloon plugged with a slug. Neck down only means that you start with a straight wall casing, but that's another term for it mostly. In a shorter barrel, all the energy needs to be imparted before the bullet leaves, so a faster burning powder is needed in pistols, and at that point a bottleneck cartridge may or may not be an advantage of any kind, simply because you're ending up doing a lot of the things that would approximate a really long skinny cartridge in it anyway. See also using deliberately 22 caliber shorts or even shorter in very, very long rifled barrels in a pistol, just to force them to have a very linear movement while rotating a very small pellet. A rifle bullet spends more time in the barrel than a pistol bullet, so longer, narrow cartridges can use slower burning powders for a more steady pressure over time, developing higher overall velocity. More powder behind, a smaller rounds make a higher velocity. That makes a flatter trajectory and a smaller package overall. Thanks for watching. Have a good day. Good luck with that pre-statement for the end. Now, why did I do this? These are all of the factors that affect why a person would use this, and these are all of the things that happen when you use a bottlenecking. That's it. There's no one answer. There's hundreds of little dinky answers. You build it, test it. If it works better, you keep it. If it doesn't, you don't. Practicality is dominant here. It has nothing to do with idealism, math, or some magic formula. It never has. See also the fact that there are hundreds of varieties of bottleneck cartridge. There is no one true perfect cartridge for any one purpose. They're all for different purposes. Thanks for watching. Have a good day. Good luck with that.